everyone, this video is for lesson 5, constructing a hexagon. And we are going to start by just incorporating 2 prior lessons, both constructing an equilateral triangle as well as copying a segment. So what we're going to do is we're going to construct the equilateral triangle using the length of QR, but we actually want each side of the triangle to be twice the length of QR. So to start with this, I'm going to use this segment and work off of this segment. So first, I have to find the length that's twice QR. So I'm going to copy segment QR again to get the segment length that's twice that length. So to start, I'm going to start at Q and extend a ray through R. Now I'm going to take my compass and I'm going to copy the length of QR onto the ray. So here's QR. I need twice the length, so I'm going to move my compass, and now I've just copied QR. I'm going to label this endpoint now P. So I really want to use QP as the side of a triangle. So I'm off the side, just going to put a little note. We are now using QP as the side length of the equilateral triangle. Of course, there are other ways to do this. You can go ahead and start with a brand new segment. I personally prefer to use the segment that was given just because it wasn't clear in the directions what they wanted. So that means I get to pick. Okay, so now we're using QP as the side length of the equilateral triangle. So what I'm going to now do is construct the equilateral triangle. Remember, we're using length QP, so I'm going to go from Q all the way to P. And oh no, I have a little issue. So unfortunately for me, I have to group this together and make it a tad smaller, just for myself. And although I'm making this smaller, it doesn't change my construction. So here I have it. And I can't go above because I have my wording there. So I'm going to take this length and I'm going to swing an arc underneath. Remember, first arcs in equilateral triangles should be rather large. I now need the intersection, so I'm going to flip my compass and I'm going to go to the other endpoint P. I could show I measured. Oops. I can show I measured by doing a little arc here. Oh, I don't know what's happening. Technical difficulties. There we go. And then go all the way down. And as we discussed in the last lesson, this is not a triangle until I connect the intersection to the 2 points. And I'm going to label my third vertice M. It wasn't specific in terms of what we needed to label that third point. We will, in the future, once we start really kind of assessing you, we'll tell you what we want everything to be labeled as. Okay. And there we go. So we doubled QR to be QP, and then we use QP as the side length for that equilateral triangle. All right, so now let's move into today's topic and our lesson. We are going to be working with hexagons. So here's a series of questions, and you can kind of read them. What is a hexagon? And then what's a regular hexagon? And think about it. I'm going to talk about what is a hexagon. So truthfully, a hexagon is a polygon because it's a closed-sided figure with straight edges. And it actually has 6 sides. So a polygon with 6. But there's a difference between a hexagon and a regular hexagon. And in our course, we're going to be using that term regular quite often. So as soon as you see regular in front of any polygon, so if you have a regular pentagon, a regular decagon, so on and so forth, when they say regular, what they're referring to is that that hexagon, in this case, has all sides and angles equal. So what is a regular hexagon? It's a hexagon with 6 equal sides and 6 equal angles. If you think about it, an equilateral triangle is kind of like a regular triangle, right? Because that had 3 equal sides and 3 equal angles. It's just more specific. We call triangles that have equal sides equilateral. And there it is. So we are going to work today to construct regular hexagons. But before we get into that, I want you to take a look at this question now. 2 polygons, and they're polygons because they're figures formed by straight edges that connect. And are these both hexagons? And you might be thinking yes or no. And the answer is actually yes, they are. And the reason why they both are is it's quite simple. They both have 6 sides. So if you take a look, although this doesn't look like a hexagon, it has 1, 2, 3, 4, 5, 6 sides. This 1, 2, 3, 4, 5, 6. This one on the right, we consider though a regular hexagon. So this is a regular hexagon. Where the one on the left is just a hexagon, nothing too special about it. And there we have it. Okay. If you think about hexagons in terms of real life, so where do you see them outside of the classroom? Actually, on your compass, there is something called a hex nut or a hex bolt that's on there. Honeybees, their honeycombs actually are in hexagon shapes, and there's an actually interesting reasoning behind that, and that has something to do with like the surface area. All snowflakes, actually, when you connect the tips, form hexagons. That's kind of cool too. Okay, so hexagons really are all over the place outside of our classroom. Just don't notice it. Okay, so we're going to construct a hexagon that maybe doesn't look exactly like this, but this picture is going to help us to figure out how to construct a regular hexagon. And I'm actually going to fix this to construct a regular hexagon because we want it to be regular. We don't just want any old 6-sided polygon on there. We want a regular hexagon. And we want you to look at this diagram and think, is there anything that we've done already in this course, which there's only been 3 other lessons, that you think will be useful in constructing a regular hexagon? So you might be looking at this and saying, well, I see a bunch of triangles. And you're right. So we're actually going to be using the knowledge from an equilateral triangle in constructing a regular hexagon. And I really like that. So you're going to think back to the lesson of constructing an equilateral triangle inscribed in a circle. And we're going to construct a hexagon inscribed in a circle. So I want you to start the same way that we did the equilateral triangle inscribed in a circle. And we started by creating the circle. So I'm going to start with a point. If you'd like, you could label that point. I'm going to choose not to, just for purposes of showing you and teaching you. I don't want my screen to get all cluttered. And now I'm going to create or construct my circle. So I get to put my needle on the center, open up the compass, whatever width I'd like. I'm going to do it about this wide. And I'm going to create myself a circle. And there it is. Step 1, done. I have my circle. Back to the equilateral triangle. I started by placing a point somewhere along the circle. So I'm going to put a point on my circle right there. Seems nice. And again, thinking back to the equilateral triangle, I have my compass width because I made my circle. So now I'm going to start at that point, pick a direction. So I'm going to go upward, and I'm going to swing my first arc. I'm going to undo this because I want to make my pencil width a little bit thinner. So just hold on 1 second. Okay. And I'm going to now swing my arc again. And there it is. Remember, with the equilateral triangle, it's 1 point and 5 arcs. So I have 1 point and 1 arc. Move it, keep it the same measure, and swing another. 2 arcs. Keep going. It's like stepping around the circle. 3 arcs. 4 arcs. And 5 arcs. So 1 point, 5 arcs. So now if this was an equilateral triangle, I'd be connecting every other arc or point. I want a hexagon. A hexagon has 6 vertices. So I'm actually going to create consecutive, meaning one right after the other, arcs and points. So I'm going to go from here to here. There's one side. Here to here. Remember, I'm connecting when the arc is intersecting the circle or the point on the circle. And I begin to get my regular hexagon. There it is. So it's that equilateral triangle construction inscribed in a circle, and then I stop and I connect every intersection to get my 6 sides. Okay, so on the next page, you have all the steps. So you can go ahead and fill this in. So the first thing was you created that circle. You picked a point on the circle. Then you did what you did for the equilateral triangle. You used the width of the radius, you placed the needle on the new point, and you swung yourself an arc. Then you put a point where the arc and the circle intersected. Maybe you didn't necessarily put a point, but if you did, great. And then you moved that compass to the new point, and you repeated. You did this until you have, and remember, for this construction, you're not going to get 6 arcs, right? You essentially have 5 arcs and the initial point. Right? So you're not getting 6 arcs. It's still the first point and the 5 arcs. Then you connect all 6 points and create yourself that hexagon. And really, you're creating a regular hexagon. Okay. So what we're just going to ask you to do is go ahead and try it right here. So I'm going to do it once more. You can pause and try. And I'm just going to walk through, putting a center point, taking my compass, putting the needle on the center, opening it up, swinging an circle, excuse me. I'm going to go ahead and I'm going to pick a point on my circle. There it is. And now I'm going to take my compass, keep the radius width the same, needle on that point, and I'm going to swing an arc. If you want at this point, go ahead and put a point where the arc and the circle intersect. You don't have to, but what's important now is I follow the direction. I'm going to go now to move to my new point and swing an arc. Move to my new point and swing an arc. Move to my new point. And if you notice, my arcs aren't super small. They're not super big. Sorry about the bell if you heard that. And so I have my 5 arcs, my 1 point, and now let's get that hexagon drawn in. To make it regular, we connect all 6 intersections. Remember, it's inscribed because the vertices are on the circle. If your hexagon is floating on the inside of your circle, it is not inscribed. And there it is. All right. So let's see what happens when they're specific. We were able to construct whatever size regular hexagon we wanted. Sometimes they give you an actual side length, which is fine. And the way we get around that, or the way we use that actual side length, is we actually have to incorporate RP into our hexagon. So we're going to start the same way. We're going to start with the center point. I'm actually going to make my center point R prime so that you can kind of follow along a little bit easier while I do this. So now I'm going to take my compass And I'm going to measure from R to P. And if you think about it, the hexagon has to have a side length of RP. So that means that my circle has to have the radius of RP. So I'm going to write that up here. In order to do this, your circle needs to have the radius width of RP. Okay, so I'm now going to just take this compass width, bring it down to R prime, and give myself a circle. There it is. Now let's get the hexagon. Pick a point. Put a point here. There we go. Take your compass and repeat the steps that we did in the prior instruction. Needle on the point, swing an arc through the circle. And I'll just step around the circle. Needle on the intersection, swing an arc. I'm not quite sure why my compass is behind my drawing. It's a little confusing. Remember, we need 5 arcs. Might not be exactly accurate because my compass is being a little funky right now. It's okay. There we have it. And now make yourself your hexagon. Here to here. And the cool thing about this is I know my side lengths are RP, and I can measure them to show that. So see, I'm measuring, they're all the same length. My compass didn't change if I measure around. Okay. So that completes lesson 5, which is constructing a hexagon inscribed inside of a circle, both given a side length and allowed to pick whatever side length that you choose. Remember that in Google Classroom, there is practice for lesson 5. Please complete that on a separate sheet of paper and then upload your work into Google Classroom by taking a picture. If you have any questions, please reach out to us and we will get right back to you with an answer.